Good morning, ladies and gentlemen. On behalf of the Air Force, I thank you for giving us this opportunity. Global trends reveal that since inception, unmanned aviation is following a similar path as manned aviation, from observation to strike. Operationally, its most popular role in the last 3 decades has always been observation, or let's say ISR. Post 2021, when CIA armed the remotely piloted aircraft while combining it with persistent stare, is that the armed concept came into being for unmanned aerial systems. The next 2 decades saw its use as a strike platform for anti-terror operations. Even in this era, globally, most unmanned aerial systems continued to be used for observation only. It is only in the last 5 to 7 years that we see other roles evolving in their effectiveness. Unmanned aerial aviation is currently moving from the observation to strike and electronic warfare at a fast pace. Thus, we are seeing a proliferation of unmanned aerial systems ranging from personal, over-the-hill unmanned aerial systems of special forces to stealthy unmanned bombers to manned, unmanned teaming machines. Keeping this in mind, I will be covering my talk today under the following heads. Why do we need unmanned aerial systems? Current envisaged roles of unmanned aerial systems. The IAF vision, operational requirements, initiative towards indigenization, the challenges ahead, and recommendations that follow before we conclude. Why do we need unmanned aerial systems? In the last 3 years, we have seen many conflicts all over the world, starting from the Israel-Hamas to the Russian-Ukraine, and then recently the Israel-Iran war. In all these, we have seen the use of unmanned aerial systems to a degree and magnitude that we had never envisaged earlier. We were all used to the conventional way of warfare. In fact, it is Ukraine which demonstrated the use of unmanned aerial systems to a vast degree in comparison to even that of manned flight. A case in point is the 21st of April 25 attack of Ukraine, which took place in the Russian 4 airfields, which we all, I'm sure, are aware of, wherein, as per the news that is available, 40 strategic bombers of Russia were destroyed, amounting to billions of dollars worth of damage to Russian strategic fleet. So, why US? It is a low-cost solution for neutralizing high-value targets. We have seen it with the war against Israel and Hamas, and otherwise, cost-effectiveness, saving manned aircraft and pilot lives. This is very applicable in today's world. We have seen it at Ops Sindoor. Capability to saturate with numbers. In large numbers, it appears as a big bird, and which confuses the surface-to-air missiles systems and radars. Deception, decoys, again, was very well evident, and which saw its light in Ops Sindoor, which is utilized by the Indian Air Force. Adaptability to changing technology and integration, wherein automation and AI will play a very vast role, and success in recent operations, which I've already covered earlier. So what are the current envisaged roles of unmanned aerial systems? Intelligence, surveillance and reconnaissance, tactical employment. Now, what do we understand by tactical employment? Tactical employment is in combination with manned flight, wherein we see that the unmanned aerial system is able to penetrate into the enemy territory and find the concerned target and designate the said target, and the fighter aircraft comes and destroys the said target, being least vulnerable to surface-to-air missiles. In many other cases, tactical employment of unmanned aerial systems has been seen to guide the special forces and the ground forces and to clear the path ahead from the enemy. Bomb judgment assessment. During Ops Sindoor, we all saw the videos which were played during the news which were flashed regarding Operation Sindoor from days on. How do we get those videos? Those videos come from these unmanned aerial systems. They are able to capture images of destruction which are caused by the fighter aircraft and other means of destruction from kilometers. Combat search and rescue, needless to say, humanitarian aided disaster relief, and suppression of enemy air defenses and destruction of enemy air defenses. So the IAF vision is governed by this guiding principle. It is enabling, complementing, surpassing manned aviation. The bulk of IAF combat air power today is designed for manned operations. Unmanned aviation must first enable this combat power to increase its effectiveness and reduce its vulnerabilities. Thereafter, in increasing numbers, it should complement manned missions, again reducing vulnerability, as well as increasing effectiveness in mixed manned-unmanned missions. Both these concepts of enabling, complementing can be used simultaneously. At a later date, unmanned numbers should surpass manned numbers, allowing fewer operators to wield large numbers of unmanned machines. So the capability, understanding this guiding principle, are a swarm and a swarm of anti-drone, one-way attack capability, electronic warfare capability in unmanned aerial systems, artificial intelligence and autonomous infusion, thereby reducing the requirement of the man behind the machine. Stealthy ISR capability. While the smaller form of UAS are to a degree stealthy vis-a-vis the detection and fire control system designed against a large manned platforms, but if we need these unmanned systems to go deep into the enemy territory, and because of the vulnerability to their low speed, then we need it to be made stealthier in design. Diverse payload carrying capacity. These unmanned aerial systems can fly for longer durations, as much as 24 to 30 hours at one go. So we need to be able to carry diverse payloads so that it can be multitasked. Lighter than air ISR platforms. Now this is a new concept which the Indian Air Force is looking at. Lighter than air airships for long duration surveillance using active and passive sensors allows excellent unmanned surveillance across mountainous borders as well as overseas. While airships which rise above stratosphere have developed challenges, low medium altitude airships rising to about 10,000 to 30,000 feet with payloads between 1 to 5 tons will be much easier to design. Apart from surveillance, they can provide other uses like data relay transponders, internet providers, and later in the development cycle as motherships to carry unmanned aerial systems and loiter munitions. It would also be prudent to explore hydrogen technology for both the lift as well as propulsion, in line with the Government of India policy of making India the world green hydrogen leader. Man-unmanned teaming refers to a swarm of unmanned aircraft led by a manned aircraft. This is a niche technology being developed by leading aerospace leaders of the world. IAF has decided to invest heavily in this route of unmanned development. The man-unmanned teaming was also covered extensively during the Aero India 2025. And armed unmanned aerial systems, needless to say, has already been covered. But apart from air-to-ground munitions, we definitely need the unmanned aerial systems to be developed to carry long-range air-to-air missiles so as to decrease the vulnerability of the manned aircraft during conflict. So what are the operational requirements? They are guided by the dull, dangerous, dirty, impossible, and efficient tasks. The acronym indicates the tenets by which we will prioritize which roles to develop unmanned capabilities first. US are good at dull, dirty, and dangerous missions. In addition, They will also undertake tasks considered impossible by manned aerial platforms. For example, flying in urban terrain or over jungle canopy, and roles which are highly efficient and cost effective compared to manned aviation. For example, long endurance surveillance. Reduced base dependency. Like we all know, our adversaries' coordinates of their military airfields, we know where their assets are located. So, in case of a conflict, as we have seen in Op Sindoor, the first thing to go are these. So, what is most important is for these unmanned aerial systems not to be dependent on a base. In fact, the size, and they should be able to be used and airborne from locations which are not known to the enemy. And so that after one launch, we are able to change our locations. Similarly, the unmanned aerial systems in older years were used, or let's say the older generations had a lot of operators to use one unmanned aerial system. There is a requirement to reduce this number of operators, which has already earlier been covered, and thereby also reducing the training cost. The capability which is envisaged is long-range capability, ability to reach deeper inside enemy territory, commonality of systems, and interoperable. Now that obviously we have all our three speakers here, the Army, the Navy, and the Air Force, and if you ask them, you'll know that we have been operating these unmanned aerial systems as in the male RPA since 20 to 25 years, and still we are not able to interoperable. We are not able to interoperate each other's machines. So while we have the same, we have to each buy our own. So commonality of systems, and they should be interoperable. They should be indigenous, of course, secure and encrypted communication. Drones, as you all know, are open source. They can easily be jammed. They are on a GPS, and obviously, like we have our unmanned aerial system, the counter UAS systems are also developing at a fast pace. In fact, it is even faster than the unmanned aerial systems. So they need to be secure and encrypted. I will take this opportunity to cover what IAF has done for indigenization of, or to promote indigenization of unmanned aerial systems. Under the Make in India project, the Meher Baba competition came into being on October 2018. We have covered so far 2 of these Meher Baba competitions, which were inaugurated by Honorable Defense Minister. And I would like to say that the first, which is the Swarm Unmanned System for HADR, the first 5 companies, or let's say startups, got orders worth 700 crores from the services. The second has concluded recently in the Aero India in Feb 2025, which had the concept of Swarm US-based foreign object detection on aircraft operating systems. And collaborative US-based surveillance radar is under process. Future procurement focuses now on indigenous unmanned aerial systems. Under process is HAIL, MAIL, one-way US and payloads. The challenges are spelled out. I think we are running short of time. I'm yet to have the answer. Aerospace management is obviously needless to say. We have the Home Ministry, the Defense Ministry, and many other organizations, agencies which are working drones. We obviously need to manage the airspace for centralized and command and control. Interference is a very big challenge which we need to earmark the dedicated band. Qualification and employment of ANEs is a very big, concern at the highest level. Detection and countermeasures, radar, counter US capability, warhead, ranges, endurance, cost versus capability, one-time usage, recoverable and reusable shelf life. Indigenous capability obviously is what we are here for, and secure data links has already been covered. There are certain recommendations I would like to cover. Is first, as it has already been brought out earlier by speakers, that we need to, the industry needs to invest in R&D, cost-effective products, integrate with service networks, obviously lifestyle ecosystems towards design, development, and production, wherein we have to reduce this life cycle, maintenance and substance, and where the product is concerned, minimum signature, easy to operate with minimum manpower, autonomous, AI-enabled, and navigate in GPS-denied environment, which has already been covered. It should be modular, the payloads, common operating systems, and a secure data link.
So since we are having a paucity of time, I'll just quickly cover the CUAS system, the problems which we faced during Ops Sindoor. During in CUAS system, sir, which FTP 21 products, that is the Zen product which we got, it was operating in a ISM band. So there was a very less pickup in those Zen system. Second, which we felt there is a requirement of wideband system for our CUAS system. We also require, as already covered, a GPS spoofer. Also, we observed that primary detection was there, but however, lots of multiple false targets were observed during Ops Sindoor. So we want to remove that problem also. Also, there is no detection of hovering drones in our system as of now. Also, detection of drones on fiber, 5G and autonomous drones we couldn't pick up. And mitigation of these swarm drone at multi-directional attack, at present we have limited capabilities. Also, high elevation pickup is also a requirement from our side. These are the hard kill challenges which we want solution, that is laser, gun and HPM. We know these are the limited and we plan to integrate in a tactical scenario. Also, there is a requirement of counter swarm drone threat, which should include the radars which are either Ku-band or able to detect the hovering drones. So with this, we have given the requirements, sir. Thank you.
Thank you.